Okay, so this video is going to cover simplifying rational expressions. So first off, before we start, we need to understand what rational expressions are. So essentially, a rational expression is anything that can be written as a fraction, right? So a fraction could be as simple as 1/2, or we can have a fraction, or we can have a rational expression that has 3 terms over 3 terms. We can have 10 terms over 10 terms. They can get very complex, but essentially it looks just like a fraction. And I always say that when we look at rational expressions, we need to mirror the exact same rules as fractions, right? Because rational expressions are just fractions. They follow the exact same rules as fractions. And what we know about fractions is that whether we're adding, subtracting, multiplying, or dividing fractions, in the end, we must always check to see, can our fraction be simplified? So the simplifying step is very important because simplifying rational expressions is going to be done at the end of almost anything that we do, whether we're adding, subtracting, multiplying, or dividing. So then, to simplify rational expressions, we factor the numerator and we factor the denominator. So really, when we think about rational expressions and we see the word simplify, it's pretty much telling us to factor. Now, how can we factor the numerator and denominator? And that's going to change depending on the type of problem that we're given, because they're going to look all sorts of different ways. So my general rule is this. If we have one term in our rational expression, or if our factor is just a single term, right? So it's a single term, which means there's no plus signs, there's no minus signs. Exactly like this example that we have here. I only have one term in my numerator. And as long as all we have is one term, we just need to expand our factor, stretch it out. And what I mean by that is, take a look at the 15. All right, well, first off, in our numerator, we have 15k cubed, which is 15 times k cubed is what that is. So how can we break this up? Well, 15 is a 3 times a 5. K cubed, well, k cubed means I have 3 k's. It means k times k times k. So this is what I mean by expand the factor. If all we have is one term, stretch it out. In our denominator, we have 5k, or 5 times k. Well, 5 is a prime number. It can't be broken down. K is to the first power, which means we just have one of them. So this is the factoring part. We have factored our numerator and our denominator. Step 2, which is my favorite part, cancel out the common factors. Let's get rid of stuff. So remember, we can get rid of stuff as long as we have the same thing over itself. So remember this rule. Anytime we have the same thing over itself, it's going to cancel out and give us a 1. Which means, looking at our example, I have a 5 over a 5 that can cancel. I have a k over a k that can cancel. Looks like that's it. I ran out of things in my denominator to cancel with. So what is our answer? Well, what we get when we slap this back together. Right? So in our numerator, I have a 3 and 2 of those k's left over. So that'd be 3. And a k times a k is k squared. Put those back together. In our denominator, everything cancels out. Now remember, when everything cancels out, it's understood to be a 1. But also remember, any fraction over 1 is that same thing in the numerator. So really that 1 is pointless. We would just want the 3k squared. So expand the numerator, expand the denominator, cancel, and then put everything that's left over back together. All right, so let's take a look at another example. So here we have another example of simplifying a rational expression. So just to recap, in order to simplify a rational expression, factor the numerator and denominator. When we only have one term, which is what we have here, we only have one term in our numerator and one term in our denominator. And the only way we can factor that is by expanding it out, by stretching out that multiplication. And what I mean by that is we're going to break apart all of our factors. So in our numerator, the first thing we have is a 24. Now a 24 happens to be 6 times 4. Also, we have a to the fourth. Well, a to the fourth just means a times a times a times a. B to the fifth means we have 5 of those, so 1, 2, 3, 4, 5 B's. And our denominator, the first thing that we have is an 18. Well, 18 just happens to be 6 times 3. Now, the reason why I broke up 24 to 6 times 4 instead of 2 times 12 or something like that is because I did notice that in the denominator I have an 18. Now, once you start playing around with numbers and start noticing similarities that we have here, looking at 24 and looking at 18, I do see that I have a 6 in common with both of those numbers. So I broke up my factor to show that. 24 is the 6 times the 4, 18 is the 6 times the 3. The next thing I have in my denominator is an a, and notice that that is a to the first power, which means I just have one of them. Then I have b cubed, which means I have 3 b's. So this is the factoring part. I've expanded my numerator, I've expanded my denominator. Next step tells us to cancel our common factors. So I'm going to cancel a 6 over a 6, an a over an a, and 3 of those b's are going to cancel out. Our answer is what we get when we put the remaining factors back together. So in my numerator, I see a 4. Okay, looking at my variables, I have 3 a's left, so that would be a cubed. And then I have 2 b's left, which would give me b squared. And my denominator, the only thing I have left over is a 3, so I'm going to scooch that over. So therefore, my simplified answer, 4a cubed b squared over 3. Now you do want to take a look at your answer and make sure that there's nothing that we possibly could have missed, that there's nothing in common with the 4 and the 3, that we don't have any other factors that might be able to cancel out. Here we are done, but it's still a good thing to check in the end just to double check and make sure that we are good to go. So let's talk about another example. So, simplifying a rational expression, we have to factor our numerator and our denominator. Now here, taking a look at my numerator and my denominator, we should be noticing that we do have more than one term. Notice in the numerator, right, I have 2 terms, and our denominator, we also have 2 terms. So when you're dealing with 2 or more terms, we need to use a different technique here. So 2 or more terms tells us to use a factoring technique. And what I mean by that, so factoring techniques are things like factoring out a greatest common factor, using difference of squares, reverse FOIL, factor by grouping. Those are our different factoring techniques. So we're no longer talking about expanding our factors. We need to use a factoring technique in order to simplify it. So taking a look at our numerator first, the 8x plus 10, we need to think, how can we factor this? Now, before we use any of the factoring techniques, our first check is, do we have a greatest common factor? That should be the first thing that we check before doing any of our factoring techniques. So taking a look at 8x and 10, we do have a greatest common factor. Because if we look at our numbers, the 8 and the 10, we do have something in common, don't we? We have a 2 in common. So because we have a 2 in common, we can factor out that 2. And when we factor it out, remember, it is like dividing it out. So that's why I have this off to the side, so we can go and factor out that 2. If you need a little help remembering how to factor out or finding the greatest common factor, you should watch my video on factoring out greatest common factors. Otherwise, dividing out the 2, 8 divided by 2 is 4. Drop down the x. Plus 10 divided by 2 is 5. So when we factored out the 2, we got 4x plus 5. So I'm just going to take this and move it up to my numerator. Okay, so now that we factored out that 2, we're left with the 4x plus 5. The next thing we need to check, inside our parentheses, this 4x plus 5, can we factor that? Right? Can we keep going? Well, we've already factored out the greatest common factor, which means our next step is to see, okay, can we use difference of squares? Can we use reverse FOIL? Can we use grouping? But this does not fit any one of those. Typically when we have two terms, it could mean difference of squares, but remember, difference of squares means we have to have different signs, and both of these terms would have to be perfect squares, and we don't have that here. So we can't factor the 4x plus 5, which means let's drop down to our denominator, the 12x plus 15. Then I have two terms there, which means I need to be thinking of a factoring technique. And before even starting that, do we have a greatest common factor? Now once again, looking at my terms here, specifically the 12 and the 15, 3 can go into both of those numbers, so I know I at least have that as a common factor. So I'm going to go ahead and pull out the 12x plus the 15 so we can factor out our GCF. Now 3 does happen to be the greatest common factor here. It is the biggest number that goes into 12 and into 15. We don't have a variable in common, so it looks like 3 is the only thing in our GCF, which means let's pull that out and divide that out to see what we're left with. 12 divided by 3 is a 4, and drop down that x, plus the 15 over the 3 gives us a 5. So again, I'm just going to move this over to my denominator. We factored out the 3 and got 4x plus 5, which just happens to be the same thing that I was left with in our numerator. We already discussed that 4x plus 5 is already simplified. It can no longer be factored, which means we are done factoring our numerator and our denominator. Now we get to cancel. So our common factors, we have a 4x plus 5 that cancels with the 4x plus 5, and it looks like that is it for this problem. So we have a 2 left over in our numerator and a 3 left over in our denominator. So therefore, our simplified rational expression is a 2/3. Okay, so let's take a look at another example. So we need to factor the numerator and the denominator in order to simplify the rational expression. So taking a look at our numerator, we have a trinomial. So if we have a trinomial, that's 2 or more terms, which means we need to use a factoring technique, which means we need to start with, do we have a greatest common factor? So glancing over our trinomial here, we do not have a greatest common factor. And because we are working with a trinomial that has a leading term of a 1, we are talking about reverse FOIL. So I'm going to go ahead and draw our parentheses, and let's factor this. So these first positions here, remember that those need to multiply to get our first term here. So the only way to get a y squared in multiplication is a y times a y. Then we need to focus our attention on our last term, which is a 6. And we need to list all the different possible combinations that multiply to get 6, which is a 1 and a 6, a 2 and a 3. Now we need to find the combination that multiplies to get 6, but adds or subtracts to get 5. Now, both of our numbers would give us that situation. A 6 minus a 1 would give us a 5. A 2 plus a 3 would also give us a 5. So we need to figure out, well then, okay, well which one of these combinations is it? Which one is the correct one? Now, one of the things that can help us in figuring this out is by taking a look at our signs. First off, everything in our trinomial is positive, which means everything in our terms here also has to be positive. So if these numbers have to be positive, right, and we're adding them together here, well, is a 1 plus a 6 a 5, or is the 2 plus the 3 a 5? Well, the 2 plus the 3 is what's going to give us the 5. So I'm going to put in the 2, and I'm going to put in the 3. The 1 and the 6 could have possibly worked maybe if we would have had some negatives thrown in here, but since everything is positive, it has to be the 2 and the 3. And also remember, a 2 times a 3 is a 6, and a 2 plus a 3 is a 5. So that needs to work every time. They must multiply to get your last term, add to get your middle term. Okay, so moving on to our denominator. We also have a trinomial, which means we need to use a factoring technique, which means we need to start with, do we have a greatest common factor? Glancing over our trinomial here, we don't have a number in common. We do not have a variable in each term, so we do not have a greatest common factor here. And because, once again, we have a trinomial with the leading term of 1, we would be using reverse FOIL. Once again, a y times a y would give us this y squared, which means we need to draw our attention to the 15 and think or list all the possible factors that multiply to get 15, which are only a 1 times a 15 or a 3 times a 5. Now it has to be the 3 times the 5 because we need the combination that adds or subtracts to get our middle term, which is an 8 here. So we need the 3 and the 5 in order for that to work. Everything is positive in our trinomial, which means everything is going to be positive in these terms. Now we're done factoring. We've factored the numerator, we've factored the denominator. We can now cancel out any common factors that we have. The only common factor we have is y plus 3 over y plus 3. So putting together what we have left over, we have a y plus 2 left in the numerator and a y plus 5 left in the denominator. This is our solution. This cannot be simplified. Nothing cancels out here, so we are done with this problem. Okay, so here we have our last example of simplifying a rational expression. So, first step in simplifying a rational expression is to factor the numerator and to factor the denominator. So taking a look at my numerator and my denominator here, the first thing that I see is that I have 4 terms in each one. 4 terms generally means factor by grouping. So, if we are indeed using factor by grouping, well, what do we need to do? So remember the general steps for factor by grouping. Says that we need to group our terms. So let me rewrite our numerator here so we have a little bit more room to work with. And we generally factor our 4 terms and we break it apart into 2 terms. So we group them 2 terms and then 2 terms. And what we're doing is we're looking for a greatest common factor within each one of these groups. So kind of ignoring the second grouping, ignoring the 5y minus 10, just looking at the the xy minus 2x, we need to think, do we have a greatest common factor? And we do, because looking at our first group, I do see that I have an x in common here, so we can definitely pull out that x. We don't have anything in common with our numbers here. We don't even have a number other than a 1 here in front. So it looks like x would be the only thing. So when we factor it out, remember, it's like dividing it out. So dividing it out, x over x cancels. We drop down that y. Also drop down that minus sign. And on our second division, x over x cancels, leaving us with 2. Then we need to turn our attention to our second grouping. And we need to think the same exact thing. Do we have a greatest common factor? Well, taking a look at my numbers, 5 and 10, I do see that I do have a 5 in common. We don't have a variable in each one of these terms, so it does seem like 5 would be our greatest common factor, and it would be a positive 5. So we're going to divide out that 5 and see what we're left with. 5 over 5 cancels, leaving us with y. Dropping down the minus sign, and then 10 divided by 5 is 2. Now in factor by grouping, you should notice that when you factor out the greatest common factor, you should have this situation here. You should be left with the same exact factor inside these parentheses. And because they share this factor, right, they have it in common, we can factor out that once again. It's kind of like factoring out a greatest common factor and then factoring out a greatest common factor all over again. Do the same thing twice in one problem. So here our greatest common factor is y minus 2, so we're going to factor that out, but we need to divide it out to see what we would be left with. So dividing it out here. Y minus 2 cancels with y minus 2, leaving us with x. Drop down the plus sign, and y minus 2 cancels with y minus 2, leaving us with 5. So I'm going to go ahead and scooch this on over. Okay, so now that I moved that over, we need to look down at our denominator. So our denominator, same thing. We have 4 terms in our denominator, which means factor by grouping, which means we need to group our terms together and factor out a greatest common factor from each one of these. So taking a look at our first grouping, xy plus 3x, I see that we have an x in common here. So we're going to pull out that x and divide it out to see what we're going to be left with. X over x cancels, leaving us with y. Drop down the plus sign, and x over x cancels, leaving us with 3. Looking at our second grouping, 5y plus 15, we do have a 5 in common with our numbers. Nothing in common with our variables there, so we are going to pull out that 5, and it is a positive 5, so we're going to divide it out to see what we have left. 5 divided by 5 cancels, leaving us with y, plus 15 over 5 is 3. So, once again, factor by grouping, we should be left with the same exact thing inside our parentheses, which we do have here, which means we can factor out our greatest common factor one more time. So we have a common factor of y plus 3 that we can factor out. So let's factor that out of what we have here and see what we have left over. So in our first term over here, y plus 3 cancels with y plus 3, leaving us with x. And y plus 3 cancels with y plus 3, leaving us with this plus 5. So I'm going to move that over to our denominator. Okay, so then now that we are done factoring, the next step is to cancel. So we can cancel an x plus 5 over an x plus 5. Putting back together what we have left over, the only thing we have left is a y minus 2 in our numerator, and a y plus 3 in our denominator. That would be our simplified solution here.